This video is going to cover section 3.1, logic statements and quantifiers. So first of all, we want to think about what it means for something to be logical. When you're saying, oh, well, that makes sense, or that doesn't make sense, usually it's based on some kind of logic, okay, whether something is true or false. So before we even get to that true or false, we have to define what we're talking about. In this case, that would be a statement. So a statement is a declarative sentence that is either true or false, but not both. In other words, it's one or the other, but it can't be both. How can something be true and false at the same time? Okay, so we're going to go ahead and look at these four examples and tell whether or not these are statements, just to kind of give you an idea of what a statement is. Okay, so letter A, open the door. This one is not a statement. In fact, it sounds more like a command to me. If I tell you, open the door, is that true or false? You really can't answer that, so therefore it's not a statement. Okay. Letter B, the dog is white. This one is a statement because let's say we have a dog and it's actually brown. Okay, and I say, oh, the dog is white. Well, that's a false statement, but it's still a statement. So this one is a statement. Letter C, 645 is a large number. So your keyword here is large because large can be, it depends on I guess who you're talking to or what perspective they have on numbers. To me, 645 might seem like a large number, but to someone who studies infinite sets or anything that's, remotely in those high numbers, they're going to say, oh, that's a small number. So we really can't say this is true or false because it would depend who you're talking to. So this is not a statement either. Okay. And anytime you see words like this, large, greatest, most, those kind of words that are like opinion based almost, it's not a statement. Okay. In the year 2024, the president will be a woman. So this one, we have no way of knowing if this is going to be true or not. I mean, this is 4 years from now. So it could be true, it could be false, but it's not going to be both. So this one is a statement. Okay. We're going to go ahead and move on. Excuse me. All right, next definition. Definition: a simple statement conveys a simple idea. So in other words, I'm sorry, a single idea. So it's one idea. So the ones that we had up here, these four, these were all simple. Okay, they had a single idea. These two anyway, because these two were not statements. So these two were single ideas, so simple statements. Okay. A compound statement is a statement that conveys two or more ideas. Usually you kind of have the words and or, stuff like that in between. So it's kind of like going back to your old English class in elementary, a compound sentence would be something like, I like burgers and I like French fries or something like that. Okay. Um, so where it has two simple ideas at least. To take note that compound statements use the words and phrases, or phrases I should say, such as and, or if and only if, then. Okay, so those words are really important because those are the ones that let us know, oh, this is a compound statement. So I have a few examples here, and we're just going to identify the different statements that we have here. So in the first one, I have the dog was brown and chewing on a bone. So if I wanted to underline the two statements that you see here, I would say the dog was brown is one of them. Okay, and chewing on a bone is the second one. Okay. Second example, a triangle is acute if and only if two angles are less than 90 degrees. So here's the first part, a triangle is acute, okay? And the second idea is two angles are less than 90 degrees. And finally, I will play Call of Duty or I will play Final Fantasy VII. So I will play Call of Duty is the first statement, and I will play Final Fantasy VII is your second statement. Notice that in between all of these, we have those compound connectors, okay? Those are the ones I underlined over here, and, or, if and only if, then. We only did 3 of them here, but it's just showing you some examples of how we can see this. So with this in mind, we're going to translate this now into mathematics. So this is a very important chart because it's going to help us with a lot of the problems that are coming up in the next this chapter and the next couple units, I believe. So please pay attention in this part. We have, and by the way, this is located in your book as well. Okay, we have some statements here, and then we have the connective. So those words I was talking about, the and, or, those are right here, this entire column. Okay, and then we have something called the symbolic form. The symbolic form is this is like our math way of writing these words. Okay, so instead of saying something is not this, we would put this little symbol here, not, and then some letter, depending what we're talking about here. And then the type of statement on the end over here is what it's called. Okay, so I'm going to go ahead and use the same exact examples. Okay, just so you can see what I'm talking about, how we would use something like this. So the first thing you want to do is try to find the statements and try to find the connectives. So remember, the connectives are the ones that I circled up here. In the first example, we had that the dog was brown. So there's our statement. And let's use purple. No, sorry, we already used that one. Let's use blue. And chewing on a bone. So if I wanted to write this using something up here, okay, well, I need to label. So I know that and is right here, okay? And if you look here in the symbolic form, you have this P, this upside down looking V, and then a Q. So the P and the V are actually the statements. So that would be this part right here. This would be P, and this would be Q. I hope I said Q. If I said V, I meant Q. I'm sorry. So P and Q are the statements. The dog was brown and chewing on a bone. So this is how we label our P and Q. The and is this symbol in the middle. Okay, it's this part right here. So this would be our symbol right here. So in other words, this first example could be written as P and Q, where P represents the dog was brown, Q represents chewing on a bone. Okay, we're going to use the same idea for the next example. I'm first going to underline the statements. I have a triangle that's acute, there's one of them, and then two angles are less than 90 degrees. So just like the one before, I'm going to go ahead and label. Let's use a different color for this one. This will be my P, so it's my first statement. And this will be my Q, my second statement. And in the middle, we have this if and only if. So we're going to look for something up here that has that if and only if. It looks like it's this last one right here. So moving over to the symbolic, you can see that it's this arrow that goes both ways. Okay, so I should have an arrow that goes both ways. So all I'm going to do is just rewrite this now. So this would be P, if and only if, Q. And that's my symbolic form for this in mathematical notation. Okay, on the last one, I'm going to scroll down just a little bit. On the last one, I will play Call of Duty, or I will play Final Fantasy VII. So for that one, I can see the or right in the middle. I'm going to just circle it. I will play Call of Duty. So there's my first statement. And then I will play Final Fantasy. There's my second statement. So the statements we label with P and Q. The connectors are the ones I circle, and those I have to find in this chart and see what represents them. So in this case, that or is kind of like a V. Okay, it looks like a V, but it means or. So this would be P or Q. Okay, now I didn't talk too much about these words over here, so let me go ahead and take a look at that now. So since we ended with an or, okay, an or, the official name for that is going to be a disjunction. Okay, and I know you've seen this before because I've taught algebra 2 several years, and disjunction is something you learn about. So a disjunction is when you have something or something else. So it's symbolized with this little V looking thing. Okay. The one before that, if and only if, is called a biconditional. And we'll talk more about this in the next title, the next I think it's 3.2 or 3.3, one of them. But a biconditional is it goes both ways. So if this side is true, then this side is true. And if this side is true, then this side is true. It goes back and forth, therefore the arrows. Okay. And the last one that we kind of saw here was this V, it's kind of upside down. And this one is a conjunction. Okay, a conjunction is an and statement. And again, I'm pretty sure you saw this in Algebra 2 at some point. And it's symbolized by this upside down V, almost like a triangle without the base. Okay, this means that you have something and something else. Okay, the two that I did not cover, so that or they're not in this example, are going to be your negation, which is this one. So negation, and if P, then Q. So I don't think we talked too much about this second one right here, this one, but we are going to talk about negation quite a bit in a bit. So just really quickly, if P then Q, this is an if then statement. It's called a conditional. It's kind of like saying, well, if this is true, then this has to be true. So for example, you can say, if you study for the test, then you will pass. That would be considered a conditional statement. Yes, if you exercise, you will not gain weight, hopefully. But yeah, that would be a conditional statement. The negation I'm going to talk about in just a bit. Okay, so quick review on what these things mean. We're going to be referring to this chart quite a bit in this lesson. I'm going to scroll down, and there is that negation I was talking about. Okay, so I went ahead and repasted the definition right here of negation. Remember that this part is, let me rewrite this here. This was the statements, okay? This is the connective. This is the symbolic notation. I'm just going to put the symbol. And this is what did I have it as? The type of statement. So the name of what this is called. So I'm just going to put the type, okay? So for this one, I did want a negation is exactly as it sounds. It's kind of saying the opposite of what you have there. So we have two examples here, letter A, letter B, and I'm just going to show you how to write them, okay? So the negation of Bill Gates has a yacht. So if we're going to say the opposite of this, we would say Bill Gates does not have a yacht. Remember, we're not talking about whether this is true or false yet. We're just trying to figure out how to write these statements, okay? So the negation of Bill Gates has a yacht would be Bill Gates does not have a yacht. And if you want to use the symbol here, okay, this right here would be P, okay? So this right here represents not P. So not P has that little symbol in front, and that little symbol means you have to negate it. You have to do the opposite. Let's look at the second example. Let's use purple. So the second one says Avatar was not selected as Best Picture at the 82nd Academy Awards ceremony. So in this one, it's kind of a long one. We have it was not selected as the Best Picture at the 82nd Academy Awards ceremony. So in this one, my P is this entire thing. If I was going to do not P, okay, so for letter B, if I was going to do not P, it's kind of like you have a not and a not. So the knots are going to cancel out, so to speak. And we're going to say that Avatar was selected as Best Picture at the 82nd, kind of a long sentence, sorry, 82nd Academy Awards ceremony. and this would be considered not P. Okay, so now we know how negation works. We know how the other ones kind of work. We're going to go ahead and use these little rules to write sentences and to write symbolic notation. Okay, we're going to do quite a few examples. These take some practice. So here we have some considerations. So let's consider the following statements. So we're looking at this box right here. Okay, this is going to represent 4 different simple statements. We have P, today is Friday. Q, it is raining. Let me color code them. So we have P, today is Friday. Q, it is raining. R, I'm going to a movie. And S, I am not going to the basketball game. Okay. So what they want us to do is they want us to rewrite this using symbolic form. So I went ahead and copy pasted that part right here. If you can't see this, you can you should have written it down anyway. But it's pretty much this part right here. These two things right here. Okay. So that's what I'm looking at right now. So let's see. Letter A. Today is Friday. So right now, all I'm going to do is I'm going to match. So I have that today is Friday. And that looks like it's letter P. So I'm going to go ahead and put a P right here. And it is raining. So I have a connector. Oh, let's not use that color. Let's use, I'll use green for the connectors. So I'm going to use green for this part. That way you can see what I'm talking about. So and would be this symbol, that upside down V. Okay, it is raining. It is raining is in yellow, and that's Q. And this is pretty much my statement right here, P and Q. So for this one, P and Q. That's the answer for the first one. Okay. Letter B. It is not raining. So now I have, well, still I'm talking about raining, so I know that this is going to be yellow. It is not raining, but I have that word not. So I'm going to use green for that one because I think I used it for the one before. So not means we have to have that little symbol in front. So it would be not Q because we're talking about the raining, okay? And so there's my connector, which happens to be and again. So there's my symbol. I am going to a movie. Okay, so I'm going to a movie. That's in my baby blue color here. So I'm going to a movie. Let's see, that's R, not Q. Okay, and we're just going to write all this out in a nice little statement. So we have not Q and, so my upside down V, R. So hopefully you're getting the idea. We're pretty much just rewriting these sentences using our symbolic form over here, okay? We're going to finish the last two, and then we're going to move on. So I'm going to the basketball game. Let's see, that has to do with letter S. So I'm going to the basketball game. But notice that our original has the word not. So if this one is going to the basketball game, we have to negate it. We have to do the opposite. So we're going to have, sorry about that, we're going to have not S. So not S, okay? And then we have the word or in this one. So we have or. Or is a different symbol. It's the or is the other one. It's the one that goes up like this, like a V, okay? I'm going to a movie, okay? So I'm going to a movie is R. So it looks like letter C is going to be not S or R, okay? I'm going to do the last one without all this labeling, just to, let's see. And actually, I encourage you to try this one by yourself first, see if it comes out. I'll give you a few seconds. Okay, I'm going to circle this one because this is the one we didn't get to cover. So then would be this one right here. Okay, so it's arrow. Okay, so for this one, it looks like I have, if it is raining, so that's going to be Q. Okay, then is the arrow, just one way only. I am not going to the basketball game. That would be S. And that's it. That would give us our symbolic form for these sentences. Okay, so let's go ahead and move on. I think that's it for this side. Yeah, that's it for this side. So we're on the other side now. Thing with this unit is that some people really get it and some people don't. So hopefully you're in the prior there. If not, like I said before, you can always ask me for some more help. Okay. We have another some more examples here. This one has some weird stuff going on here. So let's take a look at that. We're gonna color code this again. We have let's see, we have P. So P is you get a promotion. Q is you complete the training. And R is you will receive a bonus. Okay. Remember that the symbols, I'm not going to go ahead and write them again, but it's the same as the ones before. So letter A says write this as an English sentence. Okay. So we need to figure out what these things are first. So first of all, P, this part is you got a promotion. So for letter A, let's do this in white. So for letter A, okay, we first start with P. So P is you get a promotion. So you get a promotion. Okay, so that takes care of this part. And then we have a connector. We have this connector right here, which if I remember correctly is and. Okay. And if you don't remember, that's okay. You can come over here, take a look, or in your notes, you should have it in your notes. Okay. So yeah, there we go. There is our upside down V is and. Okay. So you get a promotion and then we have Q. So Q is you complete the training. So you get a promotion and you complete the training. Okay. And then we have another connector. So notice here on this one, we had both of these inside this parentheses. That means that these two kind of go together with that and. So it's the same rules as it usually is for parentheses. And then we have another connector. We have this arrow here, and we actually just talked about that one in the previous example. This represents the word then. So this is then. Okay. So then R, which is you will receive a bonus. And that's it. That is our sentence for that math symbolic form right here. Okay. Letter B is having us do the opposite. So it says if you do not complete the training, then you will not get a promotion and you will not receive a bonus. So for this one, you got to be careful because we are going to have some more parentheses. The parentheses will be between the two that don't have a connector from the one before, if that makes any sense. So it's best to just kind of start as you read it. So let's see. The first part says if you do not complete the training. So it looks like that's going to be Q. So if you do not complete the training, but it says do not, so I'm probably going to have to negate that. So not Q. So let's put that over here. So for letter B, okay, we're going to start with not Q. Okay. Then, so remember then is this thing, the arrow. So then you will not get a promotion. So we have, let's see, P is this color. So you will not get a promotion. And we have that not again. So not P. So not P. Another connector and and you will not receive a bonus. So there's my R right here. You will not receive a bonus. It has a not in it, so this is going to be not R. So knots are. And here I do want to put these two in parentheses because these two are the result of this first part right here. Okay. And that's it. That would be your answer for this one. So we're going to go ahead and do, I believe, one more example like this, and then we can finally finish off with the last part. So we're going to go through this one a little bit faster. Again, I recommend try these by yourself first, and then see if you can get the correct answer. Okay. So letter A without color coding this time. Let's see if we can do that. Write P and Q. So this is, I'm going to label the connectors. P and Q, then R as an English sentence. So P is Keisha's singing style, or Keisha as I don't know how it's pronounced. We're gonna go with Keisha. Keisha's singing style is similar to Eufete's. I have no idea who these people are. Maybe you do. Okay. And there's my connector. Q. Keisha has messy hair. Or Keisha. Okay, so there's the first two part. So Keisha's singing style is similar to Yuffie's, and Keisha has messy hair, comma, because I have to put the then. Then Keisha is a rapper. Well, that's a bit stereotypical, I think. Remember, they don't have to be true. So this is just a statement, okay? And that's it. Letter B. Let's write if Keisha is not a rapper. So that would be R, but it would be not R, okay? Then, so there's my arrow. Keisha does not have messy hair, so not Q. And, so my simple and, Keisha's singing style is not similar to Yuffie's, so not P. And this all goes in parentheses. Okay. And that's it. That's how these take a little bit of practice, but they're not too difficult. Okay. We're going to go ahead and look at something called a truth value. Okay, so now we've been talking about how to write these and what's a statement and what's not a statement, but I've mentioned a couple times that we don't really care if the statement is true or not. So in other words, it could be false. Um, Now we're going to talk about a little bit about truth or false, true or false. So we have this thing called the truth value. Okay, the truth value of a simple statement is either one or the other, true or false. So basically saying it's either it's true or it's false. Okay. The truth value of a compound statement, so this one's a little bit different, okay? A compound statement, that's more than one, that's two or more. It depends on the truth values of each simple statement and its connectives. So this one, if one is true and the other is not, it depends on what connectors in between them that to conclude whether or not the whole thing is true or false, okay? And finally, a truth table shows the truth value of a compound statement for all possible truth values of simple statements. So this one I'm actually going to show you in the next two definitions, okay? And these are directly from the book. The truth table is kind of like a chart that we can make, and it shows all the possible values of a compound statement, okay? So we're going to start with the conjunction. Remember that the conjunction is the and statement. Okay, do a different color. It was kind of hard to see. This is the and statement. According to this definition, it says that the conjunction, so this notation, is true if and only if. So that means it goes both ways. Okay, both P and Q are true. So for this to be true, both statements have to be true. It's kind of like saying, um, if you're how would I put this? Well, you know what? Let me show you the chart first, and I won't confuse you too much because the next 3.2 actually goes more into this. So let's not go too crazy yet. But here's how the truth statement works. Okay, you're gonna have to follow me here. We have P, Q, and then the one that's right here, P and Q. And what we do is we make a chart like so, and we're going to list all the possible values of P and Q, okay? And I believe in your book, it's all nice and boxed up like this, but it's all right. We don't really do straight lines here, so the possible combinations of P and Q that we have are as follows. P can be true, so the statement could be true, and Q can also be true. So they can both be true. That's one possibility. They can both be false. That's another possibility. Or perhaps P is true, but Q is false. Okay? The only combination we have left is that P is false and Q is true. So all of these right here, these are all the possible combinations of P and Q being true or false, okay? So according to this definition here, so according to this is this part right here, P, let's use a different color. That part right there is true. This is only true if both of them are true. So the only time that that happens is right here. So in this case, P and Q would be true. Everywhere else, it's false. Okay. And like I said, when we start going into actual examples, maybe this will make a little bit more sense. But for now, we're just constructing what's called a truth table. So this right here is the truth table for P and Q. Oh, should have done lowercase q. P and Q. So you can see that in all the combinations, we only have one scenario, which is this one right here, where P and Q can be true. Okay. Moving on, with that in mind, we have the disjunction now. Okay. The disjunction is kind of the opposite. Instead of and, now we have an or statement. So this is an or statement. Okay. Remember that this thing means or. I don't know if you remember the Venn diagrams that we did in an earlier video, but this it relates to that directly, both of these. If something is or, it can be in one or the other and still be true. In other words, if you think about, I have a good example for this one right off the bat. Um, if you can either pass the year, okay, so like a class, if you have the 140 rule, right? So if you, let's say you fail the first semester, but you get a really good, you break even for the next semester. So that's one possibility of credit averaging, okay? Or you can just pass both semesters with a 70 and pass that way as well. Something like that. So you have different options, and in both scenarios you're gonna pass. It's gonna be true, okay? So something like that. I don't want to get too much into it, but let's see how this one works. So we're gonna do the same exact thing. I'm going to make another truth table. So we have P, we have Q, and then we have P or Q. So it's kind of like the one we did before, except the last column. So my last column is now P or Q, not P and Q. So I gotta make my table. And these are horrible lines, but you get the idea. Okay, so just like the example before, we're gonna go ahead and put all the possible combinations. We have true and true, so they can both be true. They can both be false. P can be true and Q can be false. Or P can be false and Q can be true. And that's it. We have no other combinations, okay? So, according to this definition, this one is true if and only if. So, remember that's that symbol, okay, with the arrows going both ways. If and only if P is true, Q is true, or both of them are true. So, as long as one of them is true, this is going to be true. So, this one is true because, well, they're both true. So, this goes with this part right here. Okay. False, false. Neither of them are true. Therefore, this is false. For this one, at least one is true. So therefore, this is true. And same thing for here. Okay? And that's it. So that means in this chart, this scenario works. So does this one, and so does this one. Excuse me. All right, last part here. We're going to talk about more negations with quantifiers, the other part of the title of this section. So we have this chart. It's also coming from your book, and pretty much it's a way to negate statements that are in the form of all or some. Okay, it goes back to the whole opposite. So if we have a statement that says all of this is true, to do the opposite, you say some. So the negation of all, okay, to negate this, we say some. And to negate some, we say all. That's the basic idea. Okay. So we're going to go ahead and do some examples here just really quickly. So letter A, all bears are brown. So I would look at this one here. If I'm going to negate this, I would say some bears, because I have to change it, are not brown. Okay, that's it. We just negated it right there. Let's try the next one. Oh, sorry, that's not what I meant to do. This one. So this one says no smartphones are expensive. So that would be the second statement here. And if we're going to negate that, we do some. So some smartphones, I don't know how to spell smartphones. Some smartphones are expensive. And if you think about it, common sense wise, you're just saying the opposite of what's here. So no smartphones are expensive. Well, yeah, some of them are. And that's my negation right there. Okay. And finally, some vegetables are not green. So that would be the third one right here. So the opposite of this one, the negation, is going to be that all vegetables are green. Is that true or false? Well, we don't really care about that right now. This is just showing you how to negate, because in the next unit, you will be having to negate several sentences like this, okay? So again, this is negations with quantifiers. The quantifier would be the all, the some, the no, and so forth, okay? So quantifiers, all, some, no, or none, okay? And I think that's it. Let me see. Yep, that is it. So hopefully, I know it's kind of a long video, but hopefully you understood. If you have any questions, please feel free to reach out.